As we learned in our last video, Dalton came up with the theory that atoms are the smallest particles to exist. This is actually not a true statement. As we'll learn in this video and the next, there are smaller particles that exist. But his theory is what led to much of the experimentation that helped us find those smaller particles. One of the first experiments that helped in understanding the structure of the atom was the cathode ray experiment. A cathode tube is a glass tube in which most of the air in the tube has been taken out. You may have seen this type of tube before since it's used to create fluorescent light in neon signs. Within the tube, there are two metal discs that are connected to a high voltage that cause the cathode, a negatively charged disc, to send out an invisible ray. That ray is drawn to the anode, a positively charged disc, and can be seen on the other end of the tube, which has been coated with phosphors to cause the ray to emit light. J.J. Thomson used this cathode ray setup and attached a negatively charged plate on one end and a positively charged plate on the other. He found that the ray deflected off its course, towards the positively charged plate. Since opposites attract, he realized that the particles in the ray were negatively charged. He redid this with opposite ends of a magnet and found that the ray deflected again, further solidifying that the ray was negatively charged. Thomson used his knowledge of the electromagnetic theory to find the ratio of the electric charge to the mass of the particle. Another scientist, Millikan, conducted the oil drop experiment. He used an atomizer to spray a mist of oil into the upper chamber of a split cylinder. Some of the droplets then fell through the small hole that separated the upper and lower chamber. X-rays were used to ionize the air in the lower chamber so electrons attached themselves to the droplets. Millikan could view the droplets through a microscope on the side of the cylinder. He could calculate the mass of the droplet by viewing how fast it fell, and he could also suspend the droplet by manipulating the voltage of the oppositely charged plates until the negatively charged droplet felt an upward force from its repulsion to the negatively charged plate beneath it and attraction to the positively charged plate above it. This upward force could be made equal in strength to the force of gravity, so the droplet was essentially floating. He used the voltage for suspension and mass of the droplet to calculate the electric charge of the droplet. Remember the ratio that Thomson found between electric charge and a mass of an electron? Well, Millikan used that ratio with the electric charges he calculated over multiple trials and found that the mass of an electron was 9.8 times 10 to the negative 28 grams. That's an extremely small mass, even lighter than a hydrogen atom, the lightest element on the periodic table. These two experiments helped lead to the discovery of electrons, a negatively charged particle that exists within atoms. So, using this knowledge, Thomson came up with the plum pudding model of the atom. You might not know what plum pudding is, I didn't, but we can also use a watermelon to explain this. Guys, seriously, I needed that watermelon to demonstrate Thomson's theory of the structure of the atom. Guys? Thanks, I guess. Basically, Thomson hypothesized that electrons were surrounded by a positive volume. In this watermelon, the pink part would be the positive volume and the individual seeds would be the electrons. This is not how we view the atom today, but his theory was the first to take into consideration the existence of electrons. Come back next week for part 2 of this video, The Structure of the Atom, where we learn about the discovery of the neutron as well as how we went from the plum pudding model to the current model of the atom. Please like, share, comment, and subscribe for more videos every week.